In this question, we know that the probability density function of capital X equals to this, and we can use the probability density function to calculate the probability distribution function of random variable capital X, which is should be this. And because the random variable capital X is uniform distributed between -1 and 1, so we can write this is probability distribution function as this. And when x is bigger or equals to 1, it is obvious that the distribution of capital X is equals to 1. So we can draw the figure of the distribution function of capital X, which should be this. And we suppose that y equals to gx, and such that the probability density function of capital Y equals to e to the power of -y and multiple uy. And if we know the probability density function of random variable capital Y, and we can use this condition to calculate the probability distribution function of random variable capital Y, which should be capital F capital Y equals to integral from negative infinity to y e to the power of -t and multiple u t dt. And because this is the step function, and we can using the property of step function, and we can calculate the result should be 1 minus e to the power of -y and multiple u y. And we can also draw the figure of probability distribution function of capital Y, which should be this. Y. And we can see that f x x and f y y, they are all increasing function. And suppose that gx, and we can suppose that gx is gx is a monotonic increasing function, such that when we such that the equation gx equals to y0 has only one solution, and which is capital X0, which is X0 and between -1 to 1. And then we can use the definition P y is equals to or smaller than y0, and the probability of this, and this should be equals to P g x smaller or equals to y0. And we have supposed that gx is a monotonic increasing function, and the gx equals to y0, it has only one solution. So because it is we suppose that gx is a monotonic increasing function, so we can write this into this format. The probability of P, the probability of capital X smaller or equals to x0, and this part we can use the probability distribution function above and to calculate these two parts. And because they are equal, so we have 1 minus e to the power of negative y0 equals to 1 divided by 2 multiple x0 plus 1 divided by 2. And because we the y0 and x0 are all in the x0 is between -1 and 1, and the y0 is bigger than 0, so we can write the distribution function into this format, and we can find the relationship between y0 and x0, which is y0 equals to negative ln 1 divided by 2 minus 1 divided by 2 multiple x0. So we can find the relationship between y and x, which should be y equals to negative ln 1 divided by 2 minus 1 divided by 2 multiple x0. Yeah, x, oh sorry, it should be this x. And this is the second question.